Welcome to lesson 29, talking about rounding and estimating. These concepts you've been working with for a very, very long time, and so we're going to go through them hopefully very quickly. First of all, we get a problem like this, right? Round 283 to the nearest hundred. And one way to understand rounding is to use a number line to see the relationship that's going on here, right? So I create a number line and I put it in breaking it down to tens, but I can see my 100 place values here, and by putting in a 100's place value and then marking the spot where approximately 283 is, I can say, well, which way am I going to round? Am I going to round down to 200 or am I going to round to 300? And then the obvious answer, of course, is round up to 300. All right. Now, of course, not all rounding has to deal with hundreds. It's not always to the highest place value. Sometimes it's to just a specific place value, such as the tens. Right? So if I wanted to round 283 to the nearest tens, right, I can also use the number line, as you see here. And as you look at that number line, you can understand that, okay, as I'm breaking it down, and once again, right, my dot is here in between 280 and 290. Now the question is, as you look at that beautiful smiley face, what way would you round? Would you round to 280 or would you round to 290? And of course you would say, okay, the smiley face is definitely closer to 280 than it is to 290. And so you would round down to 280. So a timeline becomes a number line becomes an important tool. All right, got my pen too close to my hand. Now, obviously, we don't always have number lines right there, though we can always draw one ourselves. So what technique are we actually using when doing this rounding? First of all, if we go back to the original problem, we would say round to the nearest 100. Right? As we round to the nearest 100, first step, we identify the place value that we want to round to. And of course, that would be 2. Right? From there, we look back and understand really this number here. All right? The 3 is automatically going to become a 0 because it's not significant. All right? But now we say, what is the place value? Right? Suddenly we have the number 28. Right? If I look back, 8. When I look at the number 8, do I round down or up? Right? So this is where we come into our rule of 5. Right? If it's greater than 5, we round up. If it's less than 5, whoops, that's not the right symbol. Less than 5, we round down. Right? I have to write an equal. If it is 5, we round up also. So because it's greater or equal to 5, 8, of course, we're going to round up. And so this number right here is going to turn into a 3, which we already determined using our number line. Right? Now, we can use the same example to help us understand the relationship between the tens place, right? Here's the tens place from this problem right here, right? I look back, 1 place value, I see a 3. 3 is less than 5, so I'm going to round down, which means that I kind of look at it as you can kind of look at it like this, like an 83. I'm going to round down to 80 instead of rounding up to 90, right? And so we get an answer of 280. The basics of rounding. Your turn. A little bit different wording, makes you think a little bit differently, but just think hard about it and you're going to do just fine. The other side of estimating can be with, okay, what about if you have fractions? What if you have mixed numbers? How do we estimate so that we can quickly solve a problem? Right? If I mentally estimate problem number 1, right, I'm going to actually show it on the board so that hopefully you're getting the same mental process that we're going through. I look at 7/10, right? 7/10, I compare it to half, okay? Tenths, it would be 5 halves is half and 7/10 is greater, so I'm rounding up. I got 6. All right, now I look at my third. Is third greater than or less than half? Okay, that of course is less than half, so I'm going to round down. So I get 3, so I'm really taking 6 times 3, which you've already solved this. You're like, why are you wasting my time? I'm done with this problem already. I'm already halfway done with the next problem. And you looked and you're mentally doing this, and so you already changed this to a 400. You're already multiplying by a 300 because of these values here. And you probably said, okay, 3 times 4 is 12, and then I add my 1, 2, 3, 4 zeros, and you're done. Maybe you didn't quite go that fast, but you have that ability now. You know your math that well. Estimation works in other ways too, right? It can help us understand shopping. Key skill here, right? It says Barb went to the store, bought 2 gallons of milk for $2.79 per gallon, a loaf of bread for $1.89, and some peanut butter. All right, looks like she's having peanut butter sandwiches. About how much should she expect to pay for these items? All right, so we set it up. We got 2 times $7. Sorry, $2.79. So step 1 is to round this. That becomes a 3, and suddenly we need about $6. So 2 times this rounded to 3, right? Gives us $6. Next, loaf of bread. So we have 1 loaf of bread. That's going to be about $2. Round that up real fast. And then, of course, we look at the peanut butter, $3.15, right? 15 cents. In this case, we can round down. And we add those together, and it's a safe bet that you're going to pay about, or Barb is going to pay about $11 for this wonderful meal that she's creating for herself. So we see that process also. Now it's your turn. Understanding estimating is also important to understanding why you estimated the way you did. So in this case, you see that Eldon calculated, I don't know how to spell. This is what happens when you create a lesson late at night when you should be in bed, right? Maybe that's what happened. It calculated the area of this rectangle to be 25.5 square inches. Is Eldon's calculation reasonable? Why or why not? Okay, so use estimation to double check his work and then explain why it is reasonable or why it is not. This is lesson 29.